Okay, so here I drew a PLC on the board, and I want to start with down at the machine, and then we'll kind of work our way up. So in our machine, we've got sensors, and we've got lights, and we've got motors, and all the things that we want to control or see things like with our lights, or maybe we've got a siren. And we've got sensors that send information to our control system. So those are all the physical devices that we want to control. And what I did is I used blue lines to indicate inputs. So those would be sensors on the machine, and we're getting an input into our PLC to tell us that someone pushed a button, or a switch is closed, or a float switch has gone up or gone down. And then the red lines I drew to indicate outputs. So to turn a motor on, or to turn a light on, or turn on a siren, any kind of thing you want the machine to do. So that's my machine down there, and it can be any kind of machine. We don't care what the machine is. We control all machines the same. In the center here, I've got my PLC. And we're using all similar PLCs in the shop here, in the lab here. They're all 7-slot chassis, and they have the wires wired into the slots, and they all have the CPU in slot 0. So every PLC in the world is not configured that way. That's just the way these ones are configured. It's a pretty common configuration, but there are other configurations that you'll see. But anyway, we've got in our PLC, we've got a power supply. That's the big section on the left. And all that does is it takes in 120 volts and it transforms it into 24 volts. So we want all our controls to be on 24 volts with these PLCs. Some PLCs in industry actually use 120 volts, but it's a lot safer using 24 volts. So that's what we do. That's what a lot of industry does now too. Okay, so we've got our 7 slots. And remember with PLCs, whenever they number things, they number from 0 to whatever they're going to. And I don't know why they did it that way. It would be nicer, I think, if they went from 1 to 7, but they don't. They go from 0 to 6. So you have to remember that. And then inside each card, 16 channel cards are one of the most common, and that's mostly what we have here. And again, with those, they don't number from 1 to 16, they number from 0 to 15. So you have to kind of always remember that. It's always going to start with a 0 instead of a 1. Okay, the other thing I drew on here that's a little bit different is I've got some of my outputs from a card in slot 2, and I've got some outputs from a card in slot 6. So when I do my address for my outputs, a wire from this one would be, it starts with O for output, and then a colon and 2 for slot 2, and then a slash, and maybe it's wire number 8. So that would be an address for wire 8 in this slot. If I wanted to use something in this slot, I would do O again, colon 6, and maybe I use slot 8 or wire number 8 again. So the address always tells you what you're using, an input or an output, which slot it's in, and which wire number it's in, so that the PLC knows where this wire is. Okay, so that's my physical PLC. Now, notice in my PLC, I've got my controller in slot 0. I've got 2 cards in slot 1 and 2. I don't have anything in 3, 4, and 5, and I have something in slot 6. Each one of these PLCs in this room is set up a little bit different. Some only have cards in the first 4 slots. Some have things in all of them. They're all a little bit different. So to work with this, your program has to know how it's set up. And that's what we do when we do our IO configuration. I'm going to talk more about that in a minute on the computer. Okay, so that's the PLC. Here's our machine that we're controlling. And then we've got our computer that we're programming and talking with. Now, the PLC doesn't need your computer. It doesn't need you. Once it's programmed, we can take our computer away and just the PLC and the machine are going to work. And that's normal operation in industry is there'll be a PLC and there'll be the machine that's running, but there's no computer associated with it. So most common people use a laptop for all this programming because maybe if you work for Chevron, your office is over on Cameo Media. Is that what it's called? Your office is in Cameo Media, right downtown Bakersfield, but the job site could be out in the oil patch. So you do all your programming in your office, and then you take your laptop out to the PLC and you upload the new program to it. You test it. Once everything's good, you pack up your laptop and you head back to the office. Okay, so in your computer, we've got two primary softwares that we use. We've got RS Links, and that just does communication. And then we've got RS Logics, and that's where we do all our programming. So for us, the most interaction we have is with RS Logics. That's what we use. The machine and the PLC, they really don't care about us. They just like talking to each other. And then we come in and talk to the PLC occasionally. So in RS Links, it has drivers. And it has probably about 12 different drivers available, but we only really use two of them. We use serial communication or we use Ethernet communication. So when we go to talk to a PLC, the first thing we need to make sure is that RS Links has the correct driver selected for the type of communication, and that it can actually communicate with the PLC. So if we can't talk, we can't do anything. Once we have the communication established, we don't interact directly with this program, but RS Logics uses that program extensively. And so we actually still use this program. We just do all of our interface through RS Logic. And that is the one of the four things that you have to learn this semester is all this communication. This is the most difficult part about PLC programming. Yeah.
How many drivers are in total are there?
So in total, I think there's about a dozen, but in reality, we only use two of them. And there's one or two more that are occasionally used, but a lot of them are just not used. And chances are probably 95% of your work that you'll do in industry will use one of these two drivers, either serial communication or Ethernet.
Also, once it's set up, it's just ran by internet.
Yeah.
Internet or not Wi-Fi. You said Wi-Fi.
They typically don't use Wi-Fi. Some of the robots use Wi-Fi, so the latest generation of control systems are getting into Wi-Fi, but PLCs that I don't think any of them use Wi-Fi, at least not yet. Any other questions about this? So this is, like I said, this is the most difficult part about PLC programming. And it's one of the four things that you have to learn this semester. And I think you guys got this.